Okay, our last set of identities come from the Pythagorean theorem. So these are called the Pythagorean identities. I'm going to show you where they come from so that you know how to build them, but in the long run, you're just going to need to know the three different identities. So first one starts with sine and cosine. If we think about our triangle in the first quadrant, we know that x is represented by cosine of theta, y is represented by sine of theta. So we've been doing that a ton. If our angles are normal one to the x-axis. So if you think about the Pythagorean theorem, in this case, if we wanted to solve for this hypotenuse, well, it would just be x squared plus y squared. And then since we're doing a unit circle, remember the whole point of the unit circle is that our radius is always 1. So x squared plus y squared would equal 1 here. So where this identity comes from is if we substitute sine and cosine into that, we get an identity that says cosine squared of theta plus sine squared of theta equals 1. So this is the base Pythagorean identity. It's used to find the other two, and it's also the most common that you will see. It's just a true statement. If you take cosine of an angle squared, add it to sine of the angle squared, it will always equal 1. The other two Pythagorean identities are just versions of this. So the first one, if we divide everything by cosine, so just a little side note just to show you again where it comes from. Here's our original. If we go through each of these, divide everything by cosine squared, and then take what we know from reciprocal and quotient identities. We know cosine divided by cosine equals 1. We know sine over cosine is tangent from our quotient identities. So sine squared over cosine squared is tangent squared. And then from our reciprocal identities, we know 1 over cosine equals secant. So the second version of the Pythagorean identities is 1 plus tangent squared equals secant squared. And then the third version, again, I'm going to start with the normal one off to the side. And you will not have to do this every time if you just remember them, but it's a way for you to build them. If we divide everything in the normal one by sine squared, then we get our third Pythagorean identity. Whoops. So notice, cosine over sine, we know from our quotient, is the same as cotangent. Sine over sine is just 1. 1 over sine is cosecant squared. So your Pythagorean identities are all these circled identities in green. Make sure you have those written down. And you're going to be responsible for knowing the bulk of these. Will give you hints, but you should be able to come up with these identities on your own. So now for a few examples of using them. So these identities can be used in many different ways, but the main goal is if you have a problem like this one, cosine squared equals 2 plus 2 sine, we have a problem where we have both sine and cosine in the equation, so we need to get rid of one of them. Well, Pythagorean identities, first off, things have to be squared to use them. So in this case, we know cosine squared is in this Pythagorean identity over here with sine squared, meaning we can turn cosine into sine. Now we're going to have to manipulate these identities a little bit. So if we know cosine squared plus sine squared equals 1, well, if we subtract a sine squared from both sides, that leaves us with cosine squared of theta is equal to 1 minus sine squared of theta. So we can take all of this 1 minus sine squared, sub it in place for cosine squared, and then the rest of the equation will stay the same. Now we've turned this into a normal quadratic with just one trig function, so we can solve it like we have been doing before. Whenever you have a quadratic, you need to set it equal to 0. So I want to keep the sine squared negative, so I'm going to add that to the other side. And then subtract the 1 to the other side. So that will leave us with a positive sine squared. We still have that plus 2 sine of theta. And then the positive 2 minus 1 turns into a plus 1. So here's where we can go into u substitution if it helps us see it better. Again, we have to factor this into 2 sets of parentheses. So u goes in the first set, 1's multiplied to be 1, and then everything's positive in here, so they're both plus. If you separate that out, we get u plus 1 equals 0 from both of them. We don't need to write that twice. So our u represented sine, we get to sine theta. If we subtract the 1 over, equals -1. And now just go to our unit circle. Sine is y. Y is -1 down here. So our only answer to this problem would be 270 degrees. So once we get through that substitution process, it just turns into a normal trig equation. It's just a matter of trying to get it all into one trig function first so that we can then simplify it and solve the rest. Okay, this next one is another fairly similar idea. We have a cosecant squared and a cotangent. So we have two different trig functions. We need to figure out how to relate them to each other. That square is your key. That Pythagorean might help you. And then if you remember, the cos go together. So cosecant and cotangent do relate in Pythagorean identities. So this Pythagorean would be cotangent squared plus 1 equals cosecant squared. So this one is already solved for. We can take all of that cotangent squared plus 1 and substitute it into where cosecant squared is. So now we have cotangent squared theta plus 1 equals cotangent plus 1. Again, we have a quadratic, so get everything to the same side. The cotangent squared will stay in place. Subtract the cotangent over. And then when we subtract that 1, those will cancel out. So it just equals 0. So now for this one, still factoring because it's still a quadratic, but this time we don't have to go to the 2 parentheses. We can just take out the GCF, take out 1 cotangent. If we divide everything by cotangent, we are left with cotangent of theta minus 1 equals 0. We have it factored, so now just split it up. Either cotangent equals 0 or cotangent minus 1 equals 0, which means it equals 1. So now back to the unit circle, we know cotangent is x over y. So for x over y to be 0, yeah, that means the numerator has to be 0. So x is 0, it's going straight up and straight down. So this one gives us 90 degrees and 270 degrees. And then from this one over here, we know for x over y to equal 1, that means x and y have to be the same. So that's a reference angle of 45 degrees. We know tangent is positive in the first and third quadrant. So our first quadrant angle would be 45 degrees. Second quadrant angle, 180 plus 45, so 225 degrees.